Do you want to know about every leopard gecko morph there is? Come along in this video and I will show you how to do it. What is up, everybody? Frank the Geeky Gecko here from Geeky Gecko Creations, and I'm here to show you how to be your own teacher and educator on every morph of leopard gecko there is. So I'm here at my local desktop, guys, and really, this is the only thing you need to do it. Okay, everybody, I just want to mention that a link to the website that I am on right now will be in the comments below, so check that out and follow along if you'd like. This is a website called Leopard Gecko Wiki. When I was first getting more heavily into leopard geckos, I want to say around 2015, I discovered this very website right here, which was a huge help to my understanding of leopard gecko genetics. Videos online are great, and that's why I will always do videos and strive to do videos and promote live streams and get live interaction, because you can ask any questions that you have live as you think of problems with, your understanding. But if I can encourage you in any way, this website is going to be fantastic for learning about leopard gecko morphs. So as you see, I already have this website saved here, but it's pretty much leopardgeckowiki.com. So you can also do a Google search for it, Leopard Gecko Wiki, and when you do, it will be about the fourth one down, leopardgeckowiki.com. And it will take you to this main page right here. So the topic of discussion today is going to be leopard gecko morphs. If you want to learn about genetics, history, care, health, or a couple community connections, you can also use these other links. But for today's video, we're going to focus on leopard gecko morphs. Once you click on leopard gecko morphs, it will take you to the whole list of recorded morphs that we have for leopard geckos for the most part. I don't know who's actually keeping this list up to date, but I can tell you 5 years ago when I was studying it, you're pretty much going to get at least 90% of what you need to know of the morphs that are out there from this website. There might be a couple exceptions with maybe some newer combinations or some renamed combinations, but if you study this page, you will absolutely get the basics on everything you need to know about leopard gecko morphs and how to understand combinations and the base of combinations. So starting at the top, a leopard gecko morph is a difference in color, size, or genetics. Currently, there are many leopard gecko morphs available. There are recessive morphs, there are dominant morphs, there are incomplete dominant morphs. And I really like how they use the word incomplete dominance, because in the ball python community, most people will say co-dominance when that's not the correct term. And then of course they mention codominance right here, and polygenic, which is getting into line bred traits. So let's start with the good old classic Tangerine, right? So you click on Tangerine and it gives you a basic breakdown of what the Tangerine gecko is with a couple illustrations. So a Tangerine is any leopard gecko that shows tangerine or orange hues in their body color. The tangerine colors also show up in all three strains of albino. So that would be Tremper albino, Bell albino, and Rainwater albino, which we will get to later in this video. The amount of spots on the back of the leopard gecko, the amount of carrot tail, and the amount of head spots further breaks the tangerines into different categories. There are super hypo, which means no spots at all. There are carrot tails, which means that the tail will mostly be orange. There are baldies, which means that the gecko does not have pattern on its head. There are just, regular tangerines that have all of that stuff but orange color. And super hypo tangerines. So they kind of repeated themselves there. Super hypo tangerine carrot tail and super hypo tangerine. They kind of separated those two. So one is with the carrot tail, the other is with the non-carrot tail. And as you can see, these ones would pretty much be very low expression carrot tail. It has some orange there, but it's very, very low expression. You can click on the picture to try to get a better thumbnail. Actually, you know who runs this website. Let's get with them on maybe getting some more up-to-date photos. So let's take another one that is confusing to people. Let's take the blizzard and the Murphy's patternless. So let's look at what a blizzard is. Now this is a midnight blizzard, which is just a dark blizzard. But we're going to go over to Blizzard right here, and we're just going to look at the base Blizzard Morph and what it is. The Blizzard Morph, discovered by Jay Villa of Prehistoric Pets, woohoo, shout out to Jay, is very similar to the Murphy's Patternless Morph, but it is not the Murphy's Patternless Morph. Like the Murphy's Patternless Morph, the Blizzard Morph is a simple recessive morph. And anytime the word is highlighted in blue, that means you have a link, so you can click on that to understand what that word means on a deeper level. So here's the definition for recessive. A gene which is recessive only shows their effect if there are 2 copies of the gene in the pair of alleles from the parents. So what that means is each parent must pass on a copy of that gene. This uppercase P and this uppercase P is not a copy of the recessive gene. Recessive morphs are often characterized by lowercase letters. So you can see these 2 letters here are lowercase. This is the dad's genetics up top. This is the mom's genetics on the side. When you bring this P down and this P over, you get a regular non-recessive animal here. Here you get 2 heterozygous animals, which means they're carrying 1 copy of the recessive gene. And here, when you carry this P down and this P over, you get an animal that is actually visually recessive. It has 2 copies of the lowercase letters, which means it has 2 copies of the actual genetic mutation, which means it is visually displaying that specific mutation trait. As hatchlings, blizzards are completely patternless, and their colors will vary from white to yellow to deep purple. As they grow older, most change within the color scale mentioned previously. The darker blizzards are usually marketed as midnight blizzards, but there seems to be nothing which controls the dark pigment. So basically just selective breeding. If you hold back the darkest ones, you're pretty much going to get more dark babies, or at least stand your best chance. The more yellow blizzards are often marketed as banana blizzards, but a true banana blizzard is a Murphy patternless blizzard. So that is double recessive, Murphy's patternless and blizzard. So that's 4 different genes at work that have to hit to get that specific combination. Another trait which seems to randomly pop up with blizzards is snake eyes or solid eyes. So they can have all solid blizzard eyes, all solid black eyes, or they could have snake eyes, which is like half black eyes or partial. There is nothing genetic behind the snake eyes or eclipse eyes in blizzard. Most people have them randomly pop up. So pretty cool definition of blizzard here. And before we leave blizzard, let's take a look at some pictures here. So here is a blizzard female. You can see that she has the blizzard eye. She has all black in her eye, black shading right there. The eclipse gene is an actual recessive gene, which is different than the blizzard gene. But for some reason, the blizzard gene actually is separate or independent of the eclipse gene. And still, the blizzard gene can cause these kinds of eye pigment changes to occur. Now, here's another picture of a blizzard that they have on file. So the thing that separates blizzards from Murphy's patternless mostly is a uniform color. So from the tip of its nose to the tip of its tail, it's pretty much going to be the same color, as you can see in this gecko right here. When we go over to Murphy's patternless, you will see that that is not the case. Remember, these are 2 different genes. So just taking a quick look at the pictures of Murphy's patternless, this gecko is yellow from the tip of its nose to the base of its tail, and then it's orange and white in the tail. This gecko is yellowish brown and then purple in the tail. And same thing with this gecko, yellowish brown and purple in the tail. That's more of a common look of Murphy's patternless. So let's see what the definition is. Originally produced by Pat Murphy in 1991, the Murphy patternless is a leopard gecko which lacks all pattern. As a hatchling, they will hatch out with lightly colored body and random tan, gray, or brown markings on the body. So a big indicator of Murphy's patternless compared to blizzard is that Murphy's patternless will actually have pattern as a baby. So if you take a look at Murphy's patternless and you look at the picture of a baby or a young gecko, you can see that this gecko right here actually has pattern. Whereas with a blizzard, like this is a blizzard right here, you can actually see that this animal has no pattern. And again, a group of Murphy's patternlesses, but all of that pattern fades out once they get older into a uniform color like this, right here. So getting back to the definition, by the age of 10 months, the markings will have completely faded and the gecko's body color will vary between yellow and a deep purple. Throughout the generations, breeders have been able to incorporate the carrot tail into Murphy's patternless leopard geckos. Carrot tail being a line-bred trait, which means that it's not inherited through heterozygous or homozygous formation. It is simply inherited through selective breeding, which is taking parents that have that trait and then breeding it to other parents that have that trait. And then the babies will have that trait. That's how carrot tail comes about. It falls into the category of line breeding, which is different than mutation breeding, which is what Murphy's patternless is. Murphy's patternless is an actual recessive mutation. Carrot tail is a mutation, but it is a line-bred trait / mutation. Marcia McGinnis from Golden Gate Geckos has a beautiful group of Murphy's patternless carrot tails. And then it continues to go on. Talks about the genetics a little bit, talks about some crosses a little bit, the albino strains. So pretty cool. You can get picture to name reference for every single morph that exists with the exception of a couple. You know, like I don't see Lemon Frost on here, which would probably be right here, because that is kind of a newer morph. It is a little bit controversial right now where a lot of breeders are trying to bury it under the carpet, forget about it, ignore it, act like it doesn't exist, because there are some tumor issues with the Lemon Frost genetic. Now, for the most part, you are going to have to go through every single one of these and kind of gain an understanding to your degree of what you want to know. When I first started, I actually printed out like every single one of these pages just so that like when I was lying in bed at night, I could read it physically instead of be on my computer or on my phone, you know, and hurting my eyes and keeping myself awake. You know, so I was really excited about genetics and morphs and I wanted a place to learn. This website is awesome, guys. Spend some time here. Get grounded and rooted in this website and go through all of these morphs and it will help you out severely. So let's take a look at a line-bred trait real quick and then we're going to talk about albinos. So here's another line-bred trait. So Tangerine is a line-bred trait. Bold stripe is also a line-bred trait. So let's see what it says. A bold striped leopard gecko is a leopard gecko where the pattern runs along its sides. You can see right there. Two lines, two, you know, pattern-like lines. Genetically, bold stripes are thought to be line-bred. Let's click on the little link. Line-bred is linked to a word called polygenic inheritance. Polygenic inheritance is often referred to as line breeding in the reptile world. It means multiple genes combined to give particular traits. So if you haven't seen my genetics lesson yet, we basically show a strand of DNA. So let's show a strand of DNA. Here is a strand of DNA. So let's first start by calling a DNA strand a ladder. It looks similar to a ladder, right? It has two sides to it and a bunch of steps that you can climb up. One side is what you inherited from your dad's genetics. The other side is what you inherited from your mom's genetics. This is called a locus point. You can see this little red strand right here. This ladder step is the DNA that meets with your mom's DNA, this purple side, to create a specific locus point of inheritance. Let's just say at this locus point is hair color. So if your mom passes on brown hair and your dad passes on brown hair, then you're going to have a baby that has brown hair. But if your mom passes on blonde hair and your dad passes on blonde hair, then you're going to have blonde hair. When talking about polygenic traits, multiple genes combine to give particular looks, which is what traits is. So that means that this green locus point, this orange locus point, this red locus point, and let's say this other green locus point, they all play a contributing factor in the gecko having the bold stripe. So again, for line-bred traits, multiple genes combine to give a particular look. Whereas with mutation traits, it's usually thought that one location is where that trait is making a difference in the parent's DNA. For example, this could be the albino step right here, the albino locus point. And if the dad has a Tremper albino and the mom has a Tremper albino gene, that means that at this locus point, you are going to inherit 2 copies of the Tremper albino gene and therefore be a Tremper albino yourself. So here, it gives some interesting information. Genetically, bold stripes are thought to be line bred, although some say they are recessive. So something you need to know about any hobby you get into, there's always going to be different stances and opinions from different people. After many years of outcrossing bold stripes to normals, it has been concluded that this morph is an incomplete recessive, which means that this morph's mode of inheritance can vary throughout the bloodline. So very interesting. I've actually never even heard of the term incomplete recessive before. I've heard of incomplete dominant. I'm guessing what this means is if the mom's DNA is a bold stripe and she passes all 4 of those locations onto you, even though the dad's DNA is not a bold stripe, I guess what this is saying is that there's still a chance of inheritance to work for you in this bloodline. I can actually vouch for that a little bit. This first year, we started with 2 pure, beautiful, and strong bold stripe females. We did not have any bold stripe males to pair to them, so we paired to them regular males. One male was a hypo that did not have a lot of pattern on his back. The other male was a regular gecko that did have a significant amount of pattern on his back. The babies that came from the hypo parent significantly had bold stripe effects. Some even had full striping carried on just by the mom's DNA and by the lack of pattern from the dad's DNA. So the dad was a blank slate, the mom was a bold stripe. That created about 6 out of 10 babies that actually had some kind of striping, and about 2 or 3 out of 10 babies that had perfect striping. It was really strong genetics. And then on the other hand, the dad that had heavy pattern on his back, his babies all popped out with more jumbled patterning on their back, but you could still see the influence of the mom's bold stripe in the patterning. It sort of takes on a stripe-ish effect. So line bred and recessive bold stripes are currently being considered the same genotype. Genetics, incomplete recessive. As you can see, the incomplete part you can't click on because this is a term that I've actually never heard of before. I've heard of incomplete dominant, but never incomplete recessive. So when you click on recessive, it's just going to take you back to our lesson on recessive, the normal one that we covered. Bold stripe crosses. So it goes a little bit into what you can breed it into, the albino lines, the Max Snow, and then of course demonstrates a very, very beautiful picture. And it's not telling us who this picture is from or what breeder this picture is from, but it's a beautiful bold stripe nonetheless. Now, like I was saying, you're going to have to spend some time and go through every single one of these, but to clear up some misunderstanding about the albino gene in leopard geckos, I just want to point out that there are 3 different albino strains that you need to research and study when first getting into leopard geckos. The first strain was the very first albino that we know that was discovered by Ron Tremper, and it's called the Tremper albino. So do a little bit of time and research the Tremper albino. The next one that was discovered was the Bell albino. So we're going to go here, Bell albino. And it gives you a little bit of a history and a breakdown on the Bell. As you can see, there's not a ton of information, but at least it lets you know that, hey, there is a difference between Bell and Tremper, and whatever information the website has will be listed here. So, like the Bell albino, also less commonly called the Florida albino, is the newest of the 3 leopard gecko albino strains and was discovered by Mark Bell. And then there is the Rainwater albino, which is right here. Rainwater or Las Vegas albinos were founded by Tim Rainwater in 1998. In comparison with the other 2 strains of albinos, Rainwaters tend to have more pink coloration and be lighter overall. So all 3 of these strains of albino were tested to be different, meaning that if you breed a Rainwater to a tremper, you are not going to get an albino animal, because in the gecko's DNA, the rainwater mutation is on this locus point, let's just say, and the tremper mutation is on this locus point. So technically, you can have a gecko that has both the tremper albino and the rainwater albino DNA mutations, because they are on different ladder rungs or locus points. And I guess from what this is saying is that this rainwater actually came before the Bell albino. But I will say that Bell albino is second in popularity compared to tremper. So tremper is first in popularity. It's the most popular albino worked with in leopard geckos. Bell is the second most popular because the eyes are light pink color. So it's kind of been discovered that in a lot of instances, the Bell albino causes one main difference between its coloration compared to the other albino strains. And it has a light pink coloration to its eye. So it creates some really cool combinations when you mix it with the eclipse gene, giving you that all red eye. Now, tremper albinos also have an all red eye, but it's a little bit deeper and darker of a red, like a ruby color. And then the rainwater albino is thought to have the darkest of the albino eyes, and you can see that right here. This is an eye shot of a rainwater albino. And again, the eyes are very important to separating and distinguishing these three morphs, so that's why you'll see a lot of eye shot pictures. However, if you ask most breeders, they will tell you that there is absolutely no way you can compare one gecko to the other if you don't know for sure without test breeding or without knowing the exact genetics of the parents that came before it. The reason is because a tremper albino can have a little bit of variance in its eye color where it's lighter, and a Bell albino can have a little bit of variance in its eye color where it's darker. You can't just look at a gecko and be like, oh, because the eye color is pink, that means it's automatically a Bell. There's still a chance that it could be a tremper and vice versa. You can't look at a tremper and say, oh, because the eye color is a little bit darker, it's automatically tremper. It could be a Bell. You can't automatically say. It's just tendencies that each one of these strains of albinos tend to have based off of observation from breeders over the years. See? Rainwaters also have the darkest eyes of the three different types of albino, but that's not a guarantee, and if you ask most breeders, they won't use that as a standard of metrics. Well, everybody, I'm here with Toothless, the Black Knight Leopard Gecko male that we have, and this video came by vote and recommendation from you guys. So I put that poll out about a week ago about what video we should make next, and the vast majority overwhelmingly voted for the Morphs video. So I hope that you guys enjoyed this video. I hope you learned something. Spend a little bit of time on Leopard Gecko Wiki, and I guarantee you will come out with a better understanding of genetics. Take that knowledge to the community, take it into your own breeding projects, and run with it. I look forward to seeing you guys in the next video, and have a Geeky Gecko great day.